Alright, so yesterday we talked about the counting principle and theoretical probability. Now today we are going to talk about experimental probability. So let's talk about the difference between theoretical and experimental. Theoretical probability is, well, here's an example. Theoretically, if you flip a coin 10 times, how many times did you get tails? The correct answer is 5. I should get 5 tails if I flip a coin 10 times because the chances are 50-50. Now, in an experiment, if I flipped a coin 10 times, would I necessarily get tails 5 times? No. So basically what experimental probability is the number of times an event occurs in an experiment over the number of times the experiment is done. So let's look at an example here. A medical study tests a new medicine on 3,500 people. It is effective for 3,010 people. Find the experimental probability that the medicine is effective. Now they tell us how many total people, so we should know from yesterday that that means that the total amount goes on the bottom. Okay, so what goes on the top? Well, the people who were, or the number of times the event occurred, it says find the experimental probability that the medicine is effective. It is effective for this many people, 3,010. So we're going to put 3,010 over 3,500. Now, that is our experimental probability, but it's not reduced. So what I'd like you to do quick is put 3,010 in your calculator and divide it by 3,500. You're going to get a decimal that looks like 0.86, which from previous chapters we should know that if you want to turn this into a percent, you got to move it 2 spots to the right. So that means it's 86% effective. So this particular medicine is 86% effective from this experiment. That's what we found out. So if you continue reading on in the question, it says, then predict the number of people in a group of 6,000 for whom the medicine will be effective. So now, if it's 86% effective in this amount of people, we're going to assume that it's going to be 86% effective of a group of 6,000 people. So we're going to have to find what is 86% of 6,000. And we should know from previous chapters that it's going to be the percent times the whole equals the part. So if I go through here, and I'm going to erase the 6,000, we should know that our percent is going to be 0.86. We do not put 86, we put 0.86, times the whole amount of the group that we're testing, which is 6,000. And if we put that into our calculator, you're gonna see that if there are 6,000 people taking this medicine and if it's 86% effective, that means 5,160 people will be affected positively from this medicine. This second example talks about using a simulation, which basically means if they tell you to toss a coin for a certain true or false question, let's say tails equals true and heads equals false. If you want to see, or if you want to simulate the correct guessing of true and false answers, you'd flip a coin because you have two choices on a coin, you have two choices on a true or false. Now, I could have you flip a coin 50 times, but that would be a waste of time and you guys wouldn't get your homework done and then you guys would be cranky. So we're just going to show you that we tossed a coin to simulate each guess. Head represents a correct guess. The results of 50 trials are at the right. So kind of go back to what this said. I know I told you guys in an example that tails is true because they both start with a T, but evidently this book didn't want to make it easy on you. So an H means that you got it correct, and then a T means you got it incorrect. So here's the trial. They flipped a coin 50 times. What I want you to do is I want you to go right now, pause the video and count how many heads and count how many tails there are. After counting for heads, I got 22 of them, which means tails would mean I got 28. Okay, so if that, according to this simulation, if I had a test full of true and false questions, okay, if I guess on all of them, you think, oh, it'd be 50-50, but that's incorrect. Okay, if you remember heads is correct, tails is incorrect, that means you only got 22 out of the 50 correct. So what is the probability of guessing, or the experimental probability of guessing correctly on a true and false 50-point test? Well, we take the correct, or the number of times we got heads, which is the correct guess, would mean we put 22 on top, and then we put the total, remember the total on the bottom, which we flipped a coin 50 times. Okay, so that means that the experimental probability would be 11 over 25. Okay, so that means you got basically a 44%. If you put that in your calculator, you got a 44% on this test because you guessed incorrectly 28 times. Now, if you look in example 2 right here, it says in example 2, compare the experimental probability, which was, we'll just go back to our original form, 22 over 50, compared with the theoretical probability. Theoretically, which we talked about in the previous chapter, theoretically, if we guess on a true and false quiz, if we completely guess on each one, we should at least get half of them right. Well, that didn't happen in our experiment. In our experiment, we actually got less than 50%. So when it says to compare the experimental probability with the theoretical, I would say that the experimental was less than the theoretical. So you should write that down in your notes. Letter B, if you try the experiment 100 times, what is likely to happen to the experimental probability? Now, this is a good point. In an experiment, if you try it more times, what's going to generally happen is it's going to get closer and closer to the theoretical probability. Meaning, we only flip this 50 times. If you were to flip this 50,000 times, you might get closer and closer to that 25 out of 50 or 50-50 shot of getting it correct or incorrect. But basically, the more times you do, and make sure you write this down, the more times you do an experiment, the more likely that it will get closer to the theoretical probability. All right, so that is it for today. I know it was a short and sweet lesson. Make sure that if you use your book and use maybe a partner for a resource with this, make sure that you guys are getting that homework done so we can talk about it tomorrow. Your homework is page 675, 1 through 15. All 15 is the challenge. Make sure you read the directions on your homework. Some of the questions seem very easy. Some of them just require a little bit of thinking, so try your best. Forget the rest. I did the rhyme, but I didn't do the crime. Yep.